All right, good morning and happy Friday. It's July 7th, and I'm planning on doing the LeetCode Daily Challenge for today. And let me share my screen here. Okay, so here we go. July 7th. Maximize the confusion of the exam. Okay, it's 8:21 in the AM, and it's time to shine. Okay, so we have key operations where we can swap stuff. So yeah, this looks to me like the game plan will be a sliding window allowing maximum of k other values. I guess like it's in max TRF, right? Arbitrary. Can make the window bigger as long as we have less than or equal to k. Different values. Okay, yeah, so we'll track, right, track count, right, so we'll do a like linear scan, right, linear scan of a sliding window, ij, tracking count of t and f as we go. All right, so let's do this. Answer key is an array of characters, and k is the maximum we're allowed to have. We'll just make it t, actually. That would be our threshold. Okay, so t and f will be our true and false count, initialized to 0 for each character and the array of characters. T plus equals integer value of c equals t. F is equal to integer value c is equal to f. Okay, so then if the maximum of t and f exceeds t, which is our threshold, that's when we have to shrink the window. So actually, we want to keep track of ij, right? So ij will be our indices. While j is less than or equal to, or less than the length of a, Cornelian variable a, it's just a sub I instead of c. Right, the I a sub or a sub j, right? The j. One. Keep track of our best solution, which we return at the end here. Best would be j minus I, right? Which would be the sliding window from I to j non-inclusive. As long as maximum of t and f is less than or equal to a threshold. Otherwise, if it exceeds the threshold, then we'll have to subtract 1. T minus equals int a sub I is equal to t. F minus equals, oops, a sub I is equal to f capital T. F, then I plus equals 1. So we shrink the window. Okay, so it should be 4, 3, and 5. 4, 4, 2, and 2. Oh, that didn't work. Let's do this. Let's fix it. And then set the best. Well, T. Right, the maximum exceeds T. Okay. That should work. Let's scoot up I. Well, okay, that didn't work. Is one. Or actually, oh, the minimum. Okay, so I mean the minimum. Actually, the minimum, not the maximum. Minimum. Right, okay, that makes sense. All right, that's cool. Let's submit it, see what happens. 821 to 826. All right, cool. That's accepted. Oops, 826. About 5 minutes for the implementation. Yeah, Python 3, which is accepted. Yay. Okay, so that's a pretty decent solution. It looks like I solved this 2 years ago. 2 years ago or so. Okay, let's see what previously came up with. Okay, so basically the same thing. T and F, I, and J. Okay. Interesting. Pretty similar to what I came up with today. All right, well, that's cool. I kind of like this solution a little bit more. And then I'll also write the solution for rest. Use the slide name and doj to find the best answer. That's for each iteration. Threshold E. When the minimum count of T inclusive for F exceeds. Okay, that sounds good. And then, yeah, let's just come up with new solutions here real quick. Oops. Python 3. Rest, oops. C++, C++. Okay, there's Python 3. Let's do this in C++. It's 8:29 a.m. and it's time to shine. Array characters, our threshold. So T and F be our counts. Actually, let's just do this and just stick it up here. Oops. Okay, then let's do this. I'll do IJ n those make tuple 0, 0, and 8 size. It's currently in for A of all those characters. And so for each while, Jesus, and T goes. Need to cast it today explicitly, actually. A sub j equals T. F plus equals A sub j equals F. Oops, F. Increment j. Threshold is exceeded by the minimum of the count of true and false. T minus equals A sub I equals T. f minus equals a sub I is equal to f, and we increment I. S is the maximum itself, and I to j, non-inclusive. I inclusive to j, non-inclusive, right? Okay, so that took about 1 minute. Uh-oh, max is not, oops, maximum best window size. Okay, that's cool. 831. Okay, yeah, that's cool. How about 2 minutes? For implementation in C++, which is accepted. Hey. All right, this one's cool. And then let's do JavaScript. The characters, our threshold, T0, F is 0, there's a count of true, the count of false, return best as our sliding window size, I inclusive to J non-inclusive. And then let's do this. Let's J and N 0, 0, and kernelity for A. J is less than N. So this goes. A sub J is equal to T. And it goes. Oops. So we're basically casting this predicate into an integer value. Increment J, so I to J non-inclusive. While there is conflict, that is the minimum kind of counts of T and F exceeds the maximum threshold T. T minus equals number sub I as the predicate equals T, and then F equals number A sub F. Okay, and next equals the maximum itself in J minus I. So the window size of I to J non-inclusive, I inclusive to J non-inclusive. Okay, so that's good. Should be cool. About 2 minutes. All right, that's cool. And let's do Kotlin, and then we'll save the best for last. That is Rust. The best being giving most difficulty. All right, so Ri, Rt, and F will be our pair counts. In. Right, yeah, that's cool. So triple 0, 0. Kernel for A. Well, J is less than N. T plus equals if A sub J is equal to T 1.0. Okay, let's say if A sub J is equal to F 1.0. Increment J. So J is non-inclusive. This will be the maximum itself in J minus I. So the window section of I to J non-inclusive, and then while the input threshold is exceeded by the minimum count of T and F, then we increment each of these by shrinking the window. F equals I is equal to F. Uh-oh. Length, since it's a string, not an array of characters. Looks good. Okay, that's cool. And then we'll do Rust. Saving the best for last here. Rust. Okay, Rust. Array of characters, input threshold. Okay, so if we're going to access the array of characters as characters rather than a string, we need to actually collect them into a vector of characters. That should work. Okay, so let mute best equals 0. Turn best to the end here. At t, mute f 0, 0. Those will be all counts. Mute I, mute j, and n. We are indices. J is n. T plus equals a sub j to t. Oops. Is 0. 0. Oops. 0. J 1. And while the threshold is exceeded, and then max, right? The minimum T now exceeds the input threshold T, and T minus equals base of I is equal to T. 1. Oops. Otherwise, 0, and then F is equal to base of I is equal to F. 1, 0. This is 1. Best equals the maximum of itself. J minus I is I third 2. Okay, that looks good. Okay, that's cool. All right. And that's all she wrote. Okay, yeah, so use the sliding window IJ to find the best answer. That is for each iteration, we tend to increase the size of the window by 1. Then we fix violations to the problem statement. To the problem statement is verbose. That should be okay. Use the sliding window IJ to find the best answer. That is for we don't just attempt to, we do. We increase the window size. Yeah, well, my English is improved, I guess, right? So use the sliding window IJ to find the best answer. That is for each iteration, we increase the window size by 1. Then we fix violation by decreasing and to fix violations, we decrease the window. Uh, hmm. Okay, that sounds good. All right, use the sliding window IJ to find the best answer. That is, for each iteration, we increase the window size by 1, then decrease the window size. Okay, that sounds good, right? Okay, yeah, pretty decent solutions. Cool. I'll catch y'all later.